All right, so we've got a fantastic story of chemical ingenuity for you. It's all about how this, totally forgotten compound got a second chance and ended up supercharging the green lubricants that could one day be in all our engines.
So here's a thought. What if the secret to making eco-friendly oil better wasn't some crazy new discovery? What if it was just an old chemical trick that's been hiding in plain sight?
Okay, so to really appreciate how clever this whole thing is, you first got to understand the problem these researchers were staring down. Now, biolubricants, they sound perfect, right? I mean, they're made from stuff like vegetable oils, they're biodegradable, great for the planet. But, and it's a big but, throw them into the high-stress, super hot world of an engine, and they have this one fatal flaw. And that weakness? It's called oxidation. You've actually seen this happen before, I guarantee it. Ever leave cooking oil on a hot pan for too long? Yeah, you know how it gets all dark, thick, and sticky? Well, imagine that happening inside your car's engine. That gunk turns into this nasty sludge that clogs everything up and can, well, lead to total engine failure. Not good.
So the obvious fix, right? Just add some antioxidants to the oil to stop it from breaking down. Easy. Except, here's where the puzzle gets tricky. Turns out, not all antioxidants are created equal. You see, the researchers had this real dilemma. They basically had two choices. On one hand, you've got phenolic antioxidants. These guys are great at stopping that sludge from forming. Awesome. But they do absolutely nothing to stop the oil from getting thick and gummy. Then you've got aromatic amines. They're fantastic at keeping the oil from thickening, but they're useless against sludge. So you're stuck. It was a classic pick your poison kind of problem. So in their search for a better phenolic antioxidant, the researchers stumbled upon this one compound called propyl paraben. And, well, let's just say it wasn't a star pupil. As you can see from this quote from an earlier study, it was a total non-starter. Its performance was so bad that everyone just kind of wrote it off as useless. Remember that name, though. But this is where our story takes a brilliant turn. A new team of researchers comes along, they look at this antioxidant that everyone else threw in the trash, and they don't see a failure. They see potential. They basically decided it was time for a chemical makeover. And their hypothesis? It was just incredibly elegant. They thought, hey, maybe the problem isn't the molecule itself. Maybe it's just too small. See, tiny molecules can just evaporate or get torn apart when things get hot. So they asked, what if we could link these little weakling molecules together to make big, long, heavy chains? Would that make them tougher? And here's exactly how they pulled it off. It's basically a two-step process. First, a step called methylation. Think of this like prepping individual threads of yarn. They used a catalyst to get each little propylparaben molecule ready to connect. Then comes step 2, polymerization. They bring in formaldehyde to act as a chemical glue. And with another catalyst, it starts linking all those prepped molecules together into these massive chains. It's the perfect analogy, really, taking a bunch of weak, individual threads and weaving them into one super strong rope. Okay, so now they've got their new supercharged formula. The theory sounds solid, right? But would it actually work when things get tough? It was time to, quite literally, put it through a trial by fire. And believe me, they did not go easy on it. This was an absolute torture test. For 24 hours straight, they cooked the oil at a scorching 150 degrees Celsius. While that was happening, they were bubbling air through it constantly to make it oxidize faster. And just to really turn up the heat, they threw in strips of iron and copper, which are metals that basically turbocharge oil breakdown. Bottom line, if the new formula could survive this, it was the real deal. So, after 24 grueling hours, the test is finally over. The moment of truth. How did our little chemical underdog do? Well, the results, they were absolutely staggering. Okay, just look at this. The base oil, with no protection, its thickness or viscosity shot up by 93%, and the original propylparaben, our useless compound, it did nothing. Still a 93% increase. But the new formula, it held the line, with only about a 40% increase. I mean, that is a dramatic, undeniable win. And they even figured out the perfect recipe, the secret sauce, if you will. The absolute best results came from a very specific ratio of ingredients. 0.9 parts propylparaben for every 1 part of that formaldehyde glue. That right there, that was the magic number. But wait, it gets even better. There was this awesome bonus perk.
The team also checked how corrosive the different oils were to metal parts. And check this out. The original stuff caused a good bit of corrosion on copper, but the new formula, it was 3 times less corrosive. So not only did it protect the oil better, it protected the engine itself better too.
So what's the big takeaway here? Let's just boil down what this brilliant bit of chemical engineering really means. The main thing to remember is this. Researchers took a compound that everyone had written off, applied a pretty classic chemical trick to it, and turned a total weakling into a heavyweight champion. They proved that for these antioxidants, simply making them bigger made them way, way better. And in doing so, they solved a huge problem for the future of green lubricants. And that leaves us with one last big question to think about. This whole experiment proved a really simple but powerful idea. So it makes you wonder, right? Where else in the world of green tech could this simple concept, making small things bigger to make them stronger, be the key that unlocks the next big breakthrough?